Let's go ahead and look at part 2 of solving radical equations. In this lesson, though, we're going to look at solutions that are going to end up being extraneous. And extraneous simply means it's going to give us a false answer or a false solution. So let's go ahead and look to see how that happens and what we do with it. So let's go ahead and look at example 1. We're going to start out with a radical, let's say x minus 3, and we'll do something with it, say add 5, and we're going to set this equal to an x. So a couple of things that we should see that are different than what our introduction was that we have an x on the other side of our equal sign, outside of our radical. This is where things are going to allow us to see those extraneous solutions. So we're going to start by solving it the same way. We're going to subtract 5 to get that radical by itself. So I have the square root of x minus 3 equal to x minus 5. Since I have the radical by itself, I can go and undo that radical by squaring both sides. So I have x minus 3 equal, if I look at x minus 5 squared, I can go ahead and multiply it out. So I get x squared minus 10x plus 25. Remember that square, we have x minus 5 times x minus 5. And I'm going to multiply or distribute my x and my negative 5 through. So I get x squared minus 5x plus 25. Add my two middle terms, I get x squared minus 10x plus 25. Remember the shortcut, we can square the first term, we can multiply the two terms together and double it. So negative 5x doubled is negative 10x, and square the last term gives me 25. And that'll always work with squaring out a binomial. Solving this now, we don't have a linear equation like we had in our earlier examples. So what we're going to do is solve this quadratic. In order to solve a quadratic, we're going to set it equal to 0. So we're going to subtract x from that side, and we're going to add 3. So now our left side becomes 0, and our right side becomes x squared minus 11x plus 28. Now our old friend factoring comes back to play. So we're going to go ahead and factor x squared minus 11x plus 28 if we can. And hopefully we can. Here we have x minus 7 and x minus 4. Now that I have two factors set equal to 0, I can set each of those equal to 0 and solve for x. So now I have x equal to 7 and x equal to 4. If you remember though, we like to go ahead and check our work to make sure it works. So if I go back up to the original and plug in 7, I get the square root of 7 minus 3 plus 5 equal to 7. And that's what we want to test. Well, here 7 minus 3 gives us 4, so I have the square root of 4 plus 5 equal to 7. Square root of 4 is 2 plus 5 equals 7. 2 plus 5 gives me 7 equals 7. So that one works for us. Let's go ahead and look at 4. Now if I replace 4 into my original, I have the square root of 4 minus 3 plus 5 equal to 4. 4 minus 3 gives us 1, so I have the square root of 1 plus 5 equals 4. Square root of 1 is 1, so 1 plus 5 equals 4. And oh no, 1 plus 5 gives us 6, so 6 does not equal 4. So we know that 4 doesn't work. We call that an extraneous solution. So we simply cross that out, and our only solution that we have to work with is x equals 7. And that's our answer. Now, do the problems become more complicated? Not a whole lot. If we look at example 2, we can take the square root of x plus 2 minus 3 equal to 2x. Here, if I go ahead and solve for the radical, I have the square root of x plus 2. Add 3 to both sides, I have 2x plus 3. I have a square root by itself, so I can square both sides. So I end up with x plus 2 equal to 4x squared plus 12x plus 9. going ahead and solving or setting it equal to 0, I'm going to subtract my x and I'm going to subtract 2. So subtract x, subtract 2, I end up with 4x squared plus 11x plus 7. Factoring this, and it does factor for us, thankfully, we have 4x plus 7 and x plus 1. Those are both equal to 0, so 4x plus 7 equal to 0, x plus 1 equals 0. Solving for x, we're going to subtract 7 and divide by 4. So I get x equals negative 7/4. Here I'm going to subtract 1, and x equals a negative 1. Now, if I plug them in, I'm going to see that negative 7/4 does not work. If I plug negative 7/4 in, I'd have the square root of negative 7/4 plus 2 minus 3 equal to 2 times negative 7/4. And I'll go ahead and let you figure that out, but it doesn't work. Negative 1, however, does work. So that's going to be our answer. We only have one solution. Now, as I said that they didn't get a whole lot more complicated, we look at example 3. And in example 3, we're going to change it up a little bit. We're going to see a rational exponent, which we all love. But we're going to see another rational exponent, and we're going to see that these two rational exponents are not the same. So what do we do in this situation? Well, let's go ahead and take one of those radicals, which is the same as a rational exponent, to the other side. And we can simply add that quantity of 3x plus 4 to the 1/4 to both sides of my equation. So I end up with 2x plus 1 to the 1/2 equals 3x plus 4 to the 1/4. Now I have to think a little bit. I want to know, well, what's going to get rid of that 1/2 as well as getting rid of a 1/4. Well, before, we would take and multiply by the reciprocal of 2. Well, if I multiply the other side by the reciprocal of 2, I still have a rational exponent. But if I were to multiply both sides by 4, my exponents by 4, I would get rid of the exponent here as well as here. And that's really what I want to look at. So what will eliminate both of my rational exponents? In this case is multiplying by 4. So if I take 2x plus 1 to the 1/2 to the 4th, remember we're going to multiply those exponents. So I have the quantity of 2x plus 1 squared equals 3x plus 4. These exponents will cancel, so it equals 3x plus 4. Now I can go ahead and do my algebra by squaring out 2x plus 1 squared, and I get 4x squared plus 4x plus 1 equals 3x plus 4. Again, I have a quadratic, so I'm going to subtract my 3x and subtract my 4. So I have 4x squared plus x minus 3 equal to 0. Go ahead and factor this quadratic, and I get 4x minus 3 and x plus 1 equal to 0. Solving for x, after I set them equal to 0, I end up with x equals 3/4 and x equals negative 1. Now again, we want to go ahead and test both of these. If I plug in 3/4, I'm going to get a true statement, but if I plug in negative 1, I'll actually end up with a false statement. So my negative 1 does not work. So again, my only solution would be x equals 3/4. Let's go ahead and take a look at another example. In example 4, let's look at the third root of 2x minus 4 equal to a negative 2. Now what we've done is we've changed up that index. Well, now we can think, what undoes the third root of a quantity? And what undoes the third root is the cube. So I'm going to take the third power to both sides. So my third root and my third power are going to cancel. So I have 2x minus 4. Negative 2 to the third power gives me negative 8. Solving, I can add 4 to both sides. So 2x equals a negative 4. Dividing by 2, so x equals negative 2. Plugging that back in should show me that it does work. So I get one solution again. We get just a couple more examples to look at. In example 5, let's say we take this 2 times the square root of x equal to the square root of x plus 6. Now notice we have a radical on both sides, but we also have a whole number out here to work with. Well, there's really nothing we can do except for to get rid of these square roots. So we're going to go ahead and square both of our terms. If I take 2 radical x and square it, remember this exponent is going to go to both of those pieces. So if I take 2 and square it, I'm going to end up with 4. The square root of x squared gives me x. So I end up with 4x, and equal the square root of a square ends up with simply the radicand. So x plus 6. Solving for x, I can subtract x from both sides. And in this case, I have a nice linear equation. I don't have that quadratic to worry about. Dividing by 3, I'll end up with x equal to 2. Now if I plug that back in, I have 2 square roots of 2 equal to the square root of 2 plus 6. Now at first glance, you say, hey, that doesn't work. Let's go ahead and look at that. We have 2 square roots of 2. 2 plus 6 gives us 8. The square root of 8, remember, we can reduce because this is equal to 4 times 2. The square root of 4 is 2. Comes out of our radical, so we have 2 radical 2. So it does work for us. I have one last example for us, and that's example 6. Let's say we have 3 plus the square root of x minus 4, and that's going to equal 2 for us. Now if I go ahead and solve this, I'm going to subtract 3 from both sides. So I get the square root of x minus 4 equal to negative 1. We have the radical by itself, so we're going to square both sides. So we end up with x minus 4 equal to 1. And adding 4 to both sides, I end up with x equal to 5. Since we had a linear equation again, we only have one solution. Now if I go back and plug this 5 in, to check it, we have 3 plus the quantity of 5 minus 4 equal to 2. 5 minus 4 gives us 1, so 3 plus the square root of 1 equal to 2. Square root of 1 is 1, so 3 plus 1 gives us 4. Oh no. So does 4 equal 2? No. So we know that this isn't a solution. Well, it was our only possible solution, so in this case we have no solution. Now if we look back up here, there's a way we can tell that it's going to be no solution before we get too much work into it and get too involved. Come back up to the step where we got our radical by itself. Notice that square root was equal to negative 1. Remember, if I take the square root of a number, I'm always going to get the positive value of it. I'm not going to be able to get the negative value. So the square root will never equal a negative. So that will tell us that we have no solution. So if at that step I had the square root of 3x minus 5 equal to negative 4, again, remember, we cannot take the square root of a negative, or to get a negative, it's always going to be a positive, so we get a no solution as well. So whenever that radical equal to a negative, we're going to end up with a no solution. And that's going to conclude our examples Just to recap, remember, we need to go ahead and solve. If we have a quadratic, we need to factor. Most all of our problems will factor for us nicely. And then we're going to go ahead and check those solutions to make sure that one of them or both of them work. And that concludes our radical equations, checking for extraneous solutions.